Section 1.5, Part 2. So we're going to do word problems in this section, and the first one says that a group of people come forward to claim $1 million lottery jackpot, which the winners are to share equally. Before the jackpot is divided, 3 more winning ticket holders show up. As a result, the share for each original winner is going to be reduced by $75,000. So how many winners are there in the original group? So let's let X equal the number in the original group, since that's our question. So number of winners in original group. Okay, so if that's the number of people in the original group, that would mean 3 more than that is the number in the final group. So X plus 3 would be the number in the final group. We also know that originally there was $1 million and it's getting divided amongst X people. And now our million is instead divided amongst X plus 3 people. So if we take the original winning minus that reduction of $75,000, that should equal the final winning amount of money that each person's going to receive. So that original is $1 million, but divided amongst X people minus $75,000. And that's going to equal $1 million divided amongst X plus 3 people. Okay. So the next thing we want to do is to multiply to get rid of those fractions. So I'm going to multiply both sides by a common denominator, which is X times X plus 3. And when we distribute in the first fraction, the X cancels, so that's $1 million times X plus 3. I'm going to distribute to the second one. That's going to be minus 75,000 X times X plus 3. And then on the right, the X plus 3's cancel, so I get $1 million X. Okay. At this point, I could keep distributing, but I do see that everything is going to be divisible by, I think, 25,000, which would make our lives a little bit easier here, right? If we divide by the 1,000, that's going to chop off 3 zeros from each of these terms. And they're both, I think they're all still divisible by 25. So let's see. That million divided by 25,000 is going to give us 40. So we have 40 times X plus 3 minus, again, the 75. So that's going to give us a 3 times X plus 3. And then that million is going to turn into, divided by 25,000, that'll turn into a 40. And then we have the X. So all I did was just divide by 25,000 on both sides, just to make life a little bit easier. Okay, so we have simpler numbers to deal with. All right, now I can just distribute. So that's going to give us 40x plus 120. Let's see, minus 3. Oops, we missed an X along the way, didn't we? This guy has to be in here. So that's going to give us a 3x squared minus 9x equals 40x. Okay, so I have, let's see, we've got the, let's see if we can fit it up here. We've got a negative 3x squared. The 40 minus the 9 is going to give us 31x. Plus 120 is going to equal 40x, and we'll subtract that 40 from both sides. So we're going to get negative 3x squared minus 9x plus 120. And actually, it looks like everything's divisible by negative 3, which would make our lives a little bit easier. So we're going to get x squared plus 3x minus 40 is equal to 0. And I believe we can actually even factor that. So that'll be x plus 8, x minus 5. Using the 0 product property, I'll get x plus 8 equals 0, or negative 8, which doesn't make a lot of sense for a number of people. Or x minus 5 equals 0, and get x equals positive 5. Again, the positive makes more sense here, so that there were originally 5 people, and that was the question. How many? There were originally. Example 9. Ornithologists have determined that some species of bird tend to avoid flights over large bodies of water during daylight hours because air generally rises over land and falls over water in the daytime, so flying over water requires more energy. A bird is released from point A on an island, 5 miles from point B. So right away we know if we have point A and point B here that this distance is 5 miles, and we see it's labeled right there. And that this is the nearest point to a straight shoreline. So if this is our straight shoreline, we know that this is a right angle because that would be the quickest way, a straight line. So the bird flies to point C on the shoreline. So here's point C on our shoreline. So it's flying that red path there. And then it flies to point D all the way over there on the right. And that is showing us where the nesting area is. We also see from the image, though not in our word problem, that the distance from point B to D is going to be 12 miles. Okay, so the next thing we see is that the bird has 170 calories of energy reserved, kilocalories, and then it uses 10 kilocalories to fly over land and 14 to fly over water. So we see this blue part right here is really our over the water, and we see really this, we can put green, I guess, for our land. So that's something to keep in mind, that it's going to take a different amount of calories depending on what we're flying over. All right, so in part C, it's asking, part A, it's asking where should point C be located so that the bird uses exactly 170 kilocalories of energy. All right, so really what we want to know is what's the distance from B to C, and that should help us to locate it. So let's let X equal, and it actually even tells us kind of here, the distance from B to C. Okay, so if we're letting X equal the distance from B to C, we have X is one leg of this right triangle, 5 is the other leg. So I can kind of use the Pythagorean theorem here. My hypotenuse squared is going to equal one leg squared plus the other leg, the other leg squared. I'm kind of jumping ahead of myself. So that would really be, if I square root both sides, only positive because, distance. That would be the square root of X squared plus 25. And that's really how far, right? So that's our miles over water. Right, that's how far we're moving over water. That's this hypotenuse right here. How many miles over water does this bird have to travel? We also know over land, if the distance from B to D is 12, we also know that the distance from C to D then should be 12 minus that X. So 12 minus X over land, right? Miles over land. All right, so from there, we really could set up an equation, right? We know that the total energy is going to be energy over water plus energy over land. So I guess we should say total energy is going to equal energy over water plus the energy over land. And we know what we want our total energy to be. It specifically says we want them to use exactly 170. So 170 should equal. All right, so how are we going to figure out the energy over the water? Well, we know that over water, it's going to take 14 kilocalories per mile. So that would be 14 kilocal per mile. And we're going to multiply that by the number of miles. So it's the square root of X squared plus 25 miles. Oops, I'm running out of space here. Okay, to that we're going to add the land energy. So we know it takes 10 kilocalories per mile. And we're going to multiply that by the land distance, which is 12 minus X miles. Okay, and now we're just going to multiply. So the miles will cancel out. That's going to give us just kilocalories. Same over here. So we have 170 is equal to 14 times the square root of X squared plus 25 plus 10 times 12 minus X. Okay, so what we can do here is really, well, we can distribute. I guess that would be a good place to start. Distribute that 10. So we have 170 is equal to 14 square root of X squared plus 25 plus 120 minus 10X. And we can start to move things away from the radical. So when I subtract the 120 from both sides, that's going to give me, let's see, that's 50 plus 10x. So 10x plus 50 is equal to 14 root x squared plus 25. And then we'll divide by 14 on, I guess we could divide by 14 on both sides. That doesn't hurt. Or we could square both sides at this point. It actually might be nicer if we just square both sides. If we do that, then we don't have to worry about fractions. So if we square both sides, really we're going to end up doing like 14 times 14 there. All right, so when we square on the left, we're going to have to do some FOIL there. That's going to give us 100x squared plus 1000x, I believe. 500 plus 500 plus 2,500 is going to equal 14 squared, which is 196 times x squared plus 25. And we can distribute. So we have 100x squared plus 1000x plus 2,500 is equal to 196x squared plus, and when I multiply that, that's 4,900. Okay. We'll move everything off to one side. I guess we might as well subtract 196x squared and 4,900 from both sides. So that's going to give us 96x squared minus 1,000x plus 2,400 is equal to 0. And now this might be quite messy. We definitely want to utilize a calculator here. I'm saying quadratic formula is going to make life the easiest in this particular situation. So we have that x is going to equal the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Definitely going to use the calculator to help us out. So this is going to give us two separate answers. We're going to get 6 2/3. We're also going to get 3 3/4. Okay, so we get two separate answers there. So it could be either 6 2/3 miles away from point B, or it could be 3 3/4 miles away from point B. And either way, that would give us 170 calories or kilocalories used in total. So either mileage would be fine. Both of these are correct answers. All right, the last question says, does the bird have enough energy to fly directly from A to D? So what would it take to fly directly from A to D? So really now we're looking at a much larger right triangle here. So if I'm working from A to D, let's see if we can shift a little bit of this information over. Just save us a little bit of space. There we go. Okay, so if we are moving from A to D, we're really looking at a different triangle here. A to D would be this right triangle here in purple, which means the bottom would be 12, the left would be 5. So we would have, let's see, that's our hypotenuse squared would equal 5 squared plus 12 squared. That's going to be 25 and 144. So that's going to be our hypotenuse squared is 169. So that means the hypotenuse equals the square root of 169. So that means our hypotenuse is 13. So then 13 is the miles from A to D. So it's 13 miles from A to D. So let's see, that's all over water. So water would be using that 14. So that's 14 kilocalories per mile times 13 miles. And let's see if that's going to give us too many calories. So 14 times 13, that's 182. Since they only have 170 to use, yeah, they're not going to make it. So they don't have enough energy. Not enough energy reserves to make that trip. So they have to hit the shore first